In this video, I'll talk about implementation of stack using linked list, that is stack using linked list. Linked list we have already studied as a topic. So linked list is a collection of nodes which will have list of elements or collection of elements. So stack is also a collection of elements, but insertion and deletion is done by using LIFO discipline. Let us learn how a stack can be implemented using linked list. So already I have a linked list here on board. This is the node structure of a linked list and this is the structure defined in C language. So everything is ready. Now there are no elements here. So first of all, let us discuss how we should insert and delete the elements. So in a stack, elements are inserted and deleted from same end. Now if you look at this linked list, there are two ends, that is left hand side this end and the right hand side this end. If I select this side for inserting and deleting the elements, then how much time it takes for inserting and deleting on this side? It's constant. If I select this side, then from the first node I have to traverse through this linked list, then only I can insert it. So the time taken here is order of n. So insertion and deletion from this end is n and this end is 1. So now you decide which side you should select for insertion and deletion. Definitely this side. Once we have learned about creating a linked list, so that time every time we were adding a node at the end, but here we will add a new node always on this end, left hand side. Now let me fill up few elements. Let us assume that this is the first element I have inserted in the stack. So stack is still here. Then I want to insert 15. So this node is inserted and the value is 15. Then one more value I want to insert 8. So this node is created and inserted, 8 is inserted. Then I want to insert one more value. So this is value 3. So this is the latest value that is inserted in the stack. So where is the pointer? So we have pointer first here on the first node. But now I will call that pointer as top. Let us say top is a pointer pointing upon first node. So now always new element is inserted from top, that is on the left hand side. Now what are the elements in the stack? 3, 8, 15, 10. Which is the topmost element? Wherever top is pointing. The first element or the first node is containing the first element in the stack. And that is the recently inserted element in the stack. Now let us see if I want to push any element, how I can push it. I should create a new node here with the help of some temporary pointer and insert the value, then make this point here on this top, and top should be brought on this new node. This is the method of inserting. So we are familiar with this one. This is inserting at index 0. How much time it takes? Constant. So we'll be selecting this side for push. Then if I want to pop a value, that is delete a value. Then if I want to pop or delete a value, so take a pointer upon first node. This is the first node. So move top pointer to the next node, then delete this node. So this node is deleted. So that's how deleting an element at index 1, that is deleting first node. We have already seen this. This is same as that one. How much time it has taken? Constant. So I have shown you how to push the element and how to pop the element, that is delete the element inside the stack using linked list. So it is same as inserting at index 0 and deleting from index 1, that is deleting first node. Next, let us look at some condition. Two important conditions are there. When do you say stack is empty? When there are no nodes, no elements, then we say stack is empty. So that time top will be null. So if a top is null, then stack is empty. So I'll write down the condition here. Empty condition. If top is equals to null, then it is empty. Then we also need one more condition, that is stack full. In an array, the size of an array was fixed, but here it is unlimited. If you want to set the size, that is your choice. But this is unlimited size. You can insert as many elements as you want. Then when do you say stack is full? If you are unable to create any new node, means heap is full, then stack is full. So if you are creating a new node and it is not getting created, then stack is full. So for that, I will write down the full condition here. Create a new node. If it is not created, then T will be null. If T is null, then stack is full. So that's all about stack using linked list. How to represent, that is using the same node structure, and from which side we should insert and delete, from this side. What is the stack empty condition? What is stack full condition? Now let us see the operations on the stack using linked list.